Hello and welcome to the live demo of our PoliMillionaire client framework. I'll briefly explain the main components of our pipeline and then go ahead with a few demo runs. Starting with Millionaire client, this was actually provided by the organizers. It handles the authentication, the session state, and bidirectional communication with the server. Here we have a few dependencies that are necessary for both the framework that we're going to use and for RAG and speech and audio modules. The usual Hugging Face logging, and then a few imports. The logging part is just responsible for formatting the output. We have also some utilities. I'm not going to go explain them in depth since they're not the main part of our pipeline. Instead, QA agent, the question answering agent, provides the interface and an abstract class from which all the agents inherit, and they need to making them implement the answer method so that they are able to answer giving question and options to the requests of the game manager. In fact, the game manager is the orchestrator that manages the agents and plays the game. It is also able to authenticate in these competitions thanks to the client, using the client mentioned above, and provides two functions: play and play speech. Play for the text mode and play speech for the speech mode, as the name suggests, and also records many metrics that were useful in order to understand what the model was getting wrong and to perform analysis on the outputs and results of our evaluation loops. After that, we have the evaluation. Before we do that, we can initialize the manager and then head on with the evaluation. We have some helper functions, compute stats and compute percentage stats, which simply compute either absolute value or percentage stats, which will be used for logging. And then we have the actual evaluator. This one runs the game for n loops, depending on the number of loops that we specify. Usually, if not specified, it goes through all possible available categories, saves the results, the metrics in a JSON file, and display function is the parameter necessary for specifying if you're going with text mode or speech mode. And obviously, we need the manager and agent to be passed. After that, we can go to prompt resources. These are necessary for few shot and role-based prompting. Online retriever. This is the RAG part, one of the first modules for the retrieval augmented generation. We have a web retriever with a re-ranker that is able to interface with different sources, for example, DuckDuckGo or Wikipedia, depending on the category that we're facing, the type of competition the model is facing. It chunks the text and applies a re-ranking method through BGE. Another part of the online retriever is actually the router. So we have the topic RAG router. This is responsible to dispatch the calls to the per topic best retrieval with the optional top K overrides. These are basically the modules responsible for RAG, and then we have the math tools. Here we have a list of functions. These functions are available to the model to call through formal JSON files. So if it provides a tool call, name of the tool and everything in a structured JSON format, is able to call these functions. These rely on both SymPy and math. We have a variety of them. We pick them up. We fix these functions based on the questions that we saw during the in the logs and during the trials. We've done evaluations using the previous pipelines. And then we have the speech processor. This is the part that is responsible of transcribing the audio files for the speech mode. We are going to go in for the demo with the context-aware speech processor. We're going with the sequential, not the sequential processing, since it performed better with respect to the concatenated option, and it also saves us time, since the server only counts after the last question has been the last option has been received, has been fetched. Gemma speech processor we will not be using for the demo. The context-aware one is the one. It's since it inherits from the speech processor, it also contains the sequential processing part. Now, the integrated agent is the main agent class. This is the one that is responsible of routing everything. So, depending on the question, if you have maths, it can use the tools if they are activated and skips RAG. Instead, for everything else, it uses RAG if the retriever is configured. In this case, it skips the math tools, obviously, since they are not needed for the other categories. It uses Llama C++ since we have decided to go with the mixture of expert model from Gemma 4, 26 billion parameters, and it doesn't fit in one GPU. We decided to go with Llama C++ since it splits the model into the two GPUs and it is much faster at inference with respect to Hugging Face. Now we can finally start loading the models. First, starting with the retrievers. These are necessary for the retrieval augmented generation part. And then this part is necessary for defining the model that we are about to use. And we're using the 5-bit quantized Gemma 4 mixture of expert model. And as you can see here, we define the tensor split since for speech, for both for speech and the retrieval and RAG modules, which will be loaded in the GPU, as you can see now, and take up a bit of VRAM. We specify the tensor split so that the actual LLM resides mainly on the second GPU and not the first one, otherwise we hit out of memory errors. We are going to use large V3 turbo, both because it is quite fast and it is light on VRAM, and the performance decrease with respect to the normal large speech model is not different at all. It's not that big. Once the model is loaded onto the GPU, we will be able to configure it. For example, we can specify if we want to use tools or not and COT. This is important. We don't simply just change the flag in the model because also the examples change. For example, if we are using COT and we would like to use few shot learning, we cannot use the same examples, the same prompt sources, since they will need to contain the reasoning behind every answer. And so hence why we use update configuration to modify also which examples the model will use. For the first demo, I will go with the speech mode. I will not be using concatenated audio. I will only run for one loop, and we will see how it goes. And then we'll do the same thing for text mode. For the text mode, I will not be using mathematics tools. Since we know, so in the first case I will be using practically everything I can, both math tools, RAG, COT and everything, and we'll see how the model actually doesn't time out at all, thanks to the Llama C++ framework, which handles inference quite well. In the second case we'll go with a lighter configuration, since we won't be using mathematics tools which add overhead to the inference, but we will still be using COT and RAG. The model still hasn't loaded completely. We can see the VRAM filling up. So usually it takes a few moments, and then we will start seeing the main loop. We went with the mixture of experts model because it was the best performing in maths. In fact, we were struggling quite a lot with maths and weren't able to achieve good performance even with the tools, since the other models that we tried just couldn't handle tools quite well. Instead, with the mixture of experts, it was able to perform arithmetics on its own as well. In fact, it does not rely on tools that much. We will see right now when we reach the maths category. As you can see here, the RAG provides additional context to every question, and depending on whether we're dealing with entertainment, news, or history, it uses different sources. And provides, through the re-ranker, the most similar sentences, the most similar text chunks to the question itself. We log the time for transcribing the audio question and for the generation of the other them. We can see here that it arrived to level 4. It reached level 4 and wasn't able to answer correctly. And then we go on to the next category. It was only able to arrive to level 1 in this case and wasn't able to earn anything. For science, we decided to not go with anything with RAG, to not enable RAG, since it was performing quite well already on its own, as we can see here. And this autoregressive trace is basically the output of the thinking part of the model. One thing we noted is that Gemma models tend to think in numbered lists. Once this loop has finished, we can check the other one and see how it goes. That will be it for the demo. Perhaps we can stop it earlier as well if needed. As you can see, there is no timeouts happening at all, and the model is actually quite fast at both answering with COT and thanks to Whisper, the transcription time is quite limited. We can see it was not able to arrive to level 15, but it's okay. Now the maths category is the most interesting one, since we will be able to see if the model called some tools or not. In this case, it did not call any tools. It was still able to answer correctly. However, in the second answer, for the second question, did not call any tools and did not answer correctly. This is basically it for the audio part. Now let's go with the text part. I stopped it early so we can move on and show you the text part. This is much faster since there is no transcription anymore, and so it's simply the RAG, the retrieval augmented generation, and the model itself that's thinking with the autoregressive part, the COT reasoning trace, and so there's no transcription overhead. Another important thing is that we kept the context of the model relatively high, around 4,000 if I'm not mistaken, in order to be able to fit all of the context given by the RAG, the question itself, and the options into the model. I will let the text part run. We'll see in maths if it is better. And actually in maths, the biggest hurdle, especially in speech part, in the speech modality, is how clear the audio is. Since it will contain formulas and specific terms, it can get quite difficult for the model to understand the question rather than just provide the answer like in text mode. Another thing that we added is we noticed that sometimes the server just doesn't accept our answer. So what we do is we wait and then we try to submit the same answer again, and it works. And this is a fallback that we added, seeing that sometimes it just would not accept the answer. Instead of just disconnecting and going to the next competition, to the next category. Depending on the retrieval budget that we said, we can skip the re-ranker and keep the context in the same order, or just retrieve the top K in the original chunks that we got without re-ranking anything. Here we can see it was able to achieve full score in history, text mode. And this is science mode, and was able to reach level 10. Now for maths, let's see if there are going to be any tool calls. We notice that the model doesn't call the tools quite often, doesn't rely on them much, even if we specifically mention that in the prompt, and which we found quite odd. Probably because either the model is not well suited for tool calling in maths, and it is already trained well enough to be able to reason and do arithmetics on its own, or simply because it does not see any need to do it. In fact, it was able to reach the full final level without any tool calling so far. In this case, it was already set to not call any tools, if I'm not mistaken. Yeah, there was no tool calling anyways. So this is the expected behavior in this case. And then we have the final two new categories, philosophy and psychology. With the new categories, we noticed that the model was performing quite well, even better than science, much better than science in philosophy and psychology. So the questions, we didn't had any problems with this category. While for the news category, in fact, it was able to reach the final level. For the last category, however, we noticed that it would suffer quite a lot because providing the right context that it needed was difficult, and the level that it reached was 4 in this case. And these are the global accuracies and metrics. Now, one thing to note is the accuracy that we're mentioning here is not true statistical accuracy as number of correct answers over total questions, but it's more of a progression rate. So it arrived to 69% of completing all of the categories. And in fact, the average level is 10.83. We can see that it excels in ancient history and politics, in science, in maths, and philosophy. While entertainment, it suffered a bit, and news is the most difficult category that remains so far. It saves the metrics to a file in JSON, and we can recover it and then check the results and both the questions and everything that has been seen by the model and the answers, and we use this for the analysis. And this is it for the demo. Hope you enjoyed it, and if you have any questions, we'll be available for the interview. Thank you.